Welcome to Spring LIB.
Okay, in this circuit, C1 is in parallel with the series combination of C2 and C3. Now, let's find out series capacitance of C2 and C3. This is given by C2 times C3 divided by C2 plus C3. That comes from the fact that 1 over C23 is equal to 1 over C2 plus 1 over C3. Now, if you simplify this equation, you get this equation. Now, to find the net capacitance of this whole system, you can simply add C1 to the C23 because C1 and C23 are in parallel. So the answer for C net is equal to C1 plus C2 C3 divided by C2 plus C3. Now, since the values are given, we can find out C net. Value of C net we can find as 32 microfarad. Value of C1 was 24, C2 was 24, and value of C3 is 12. Now, with this given value of C net, you can find out Q net, C net times V, which is equal to 32 times 35, which is 1120 microcoulomb. Also notice that Vc1 is equal to Vc23. That is, potential drop across C1 is equal to the potential drop across the series combination of C2 and C3. Now, since potential drop across C1 is equal to V, that is 35, we can find out the charge across C1, which is equal to C1 times V, which is equal to 24 times 35. This is equal to 840 microcoulomb. And if QC1 charge is deposited, remaining charge, that is Q, sorry about this, if QC1 is deposited across C1, remaining charge of this Qn is deposited on the system of C2 and C3. So this charge is given by Q net minus QC1, which is equal to 1120 minus 840. This comes from the fact that charge is always conserved. So this subtraction will give you 280 microfarad. And since C2 and C3 are in series, the charge dropped across C2 is equal to charge across C3. I hope you understand.